Okay, let's solve a problem of using the linear differential equation method. Okay, now first thing to do is to recognize if the differential equation is an is a linear differential equation. The way to check it is to check if comply or it has the shape of the linear differential equation, which is here. Remember that the first coefficient must be equal to 1. Now, why it should be equal to 1? Because we developed this integral factor from in the previous video, assuming that you have 1 here. If you don't have 1 here, then this formula doesn't work. Alright? Okay, now, for this differential equation example, I see that my first coefficient is not equal to 1. Okay? So I have to fix that before applying the formulas. Okay, so the way to fix it is to divide by x on both sides, right? So what is left? This is derivative y respect to x minus 4 over x y equal to x to the power of 5 exponential of x. And now it has the shape of the linear differential equation. This is 1, then this is my p of x, and this is my q of x. Common mistake on the students, they forget to make this equal to 1 and they assume that p of x is equal to minus 4 and q of x is equal to x to the power of 6 exponential of x. Very common mistake. I hope you don't make this mistake. First of all, make sure that the first coefficient is equal to 1 to have the correct p of x and q of x. Okay, the next step is to calculate the integral factor. The integral factor is that formula that we developed in the previous video. So w of x is equal to the exponential of the integral of p of x. In this case, p of x is minus 4 over x differential of x. Don't forget that the minus comes in the formula, alright? Here originally is plus p of x, then you have to consider this minus inside of the p of x. Okay, so let's solve this integral. Exponential of minus 4 integral of 1 over x differential of x. Alright, so exponential minus 4 the natural logarithm of x. So that is equal to, this goes here in the power, exponential of the natural logarithm of x to the power minus 4. That is a property of the natural logarithms, if you remember that property. A, the natural logarithm of b, is equal to the natural logarithm of b to the power of a. So whatever number is here goes in the power. Okay, now we can cancel the exponential and the natural logarithm. We cannot cancel the exponential and the natural logarithm here because you have the minus 4 in the way. Okay? So you have to take this in the power so that you can cancel. Now that you can cancel, then w of x happens to be equal to x to the power minus 4. Alright? Okay, now what to do with that w of x? As shown in the previous video, what we are going to do is to multiply this w of x times the differential equation. So let's do it. X to the power minus 4 times the derivative of y respect to x, and then minus 4 x in the numerator is x to the power minus 1 times x to the power minus 4 is going to be x to the power minus 5, and then equal to, times y, I forgot the y here, equal to, now, x to the power minus 4 times this is going to be x, only one x, exponential of x. Now here comes the dead step, engineers. The property of this w of x is that you can change this into the derivative of two things of a multiplication, which is x to the power minus 4 times y, and that is equal to x exponential of x. And now this is a variable separable differential equation, right? Now this is the magic of the integral factor, and here is what I call the dead step. It's not black magic, engineers. You can do this because in the previous video we demonstrated that we are capable to do this as long as we have this formula, as long as we calculate the w of x using this formula, then we are capable to do this. But for the sake of showing that it is the same, just develop the derivative of this. The derivative with respect to x of x to the power minus 4 times y. What is the derivative of this? Is the first one, x to the power minus 4, derivative of y with respect to x, which you already have here, and then plus y, derivative of x to the power minus 4, the minus 4 goes down, x to the power minus 5. And those are the numbers that you have here. The y, the minus 4, and x to the power minus 5. So this is actually the same, alright? But it's called the dead step. Pay attention on this because this is very confusing, and I recommend you to check the previous video where I explained how you are capable to do this. But now that you are capable to do this, now this is a variable separable differential equation that you can solve, alright? Now this part again is just checking. This was just a check. Checking this dead step. Check dead step is correct, alright? Okay, so because it's a variable separable, then we can solve it. The differential of x to the other side, differential of x to the power minus 4 times y minus 4 times y equal to x exponential of x, differential of x. And then let's apply the integrals, alright? So this and this cancels. So what you get here is x to the power minus 4 times y equal to the integral of x exponential of x. I can use integration by parts or use the table of the integrals. In the table of the integrals, the formula is that is going to be the integral of this is going to be just x minus 1 exponential of x. Alright. I highly recommend you to bring or to have the integral of the table of integrals in hand so that you can use it, and plus the constant. Alright. Okay, so now let's clear the y. The clearing the y is that you have y over x to the power minus 4 is actually in the denominator, x to the power 4 equal to x minus 1 exponential of x plus the constant, and then y is equal to this x to the power as a multiplication, x to the power 4 x minus 1 exponential of x plus the constant times x to the power 4. Now, if you pass this as a multiplication, it multiplies this, but also multiplies the constant, alright? It's very common for the students that multiply the x to the power 4 and only multiply in the first one, and you forget to multiply also in the constant. Okay, now this is the explicit general family of solutions. On the linear differential equations, you always get the explicit solution because you are always capable to clear the y. So let me do the note here. You always get the explicit solution on linear differential equation. And another thing, here the constant, it is a homogeneous solution, and here is the particular solution. I haven't explained what is the particular solution. I have already explained what is the homogeneous, but the homogeneous is the solution related to if the q of x is equal to 0, alright? But the particular solution is something new. But on the linear differential equation, you always get an homogeneous part of the solution which always have the constant, and a particular solution that doesn't have a constant. Okay, that is a characteristic of the linear differential equations. We are going to use that later, but this is the example to solve linear differential equations. Again, check the dead step. The dead step is very important. It's very confusing. Please check the previous video 2 or 3 times, and also check this video 2 or 3 times to understand the dead step. Next video we are going to do another example of linear differential equations. See you in the next one.